Hi, this is Pipesim Python Toolkit for beginners. Today, I'd like to demonstrate you how to control Pipesim model from Excel file, and I'll show you where you can find examples and template for your own solution. So let's start from the installation folder. Under the case studies, Python Toolkit, you can find different examples. All of them can be split by two groups. In group 1, Excel is used as a data storage only, and in group 2, Excel contains the control elements that allows user to control Pipesim model execution and results publishing. So let me demonstrate you the first group example, daily production. In this folder you see two files, Excel file and Python code file. If we open this Excel file, we can notice that this file doesn't contain any control elements. In this file we have the two tables, table with input data and table with output data. So if we want to process this file, we need to run Python code directly from the command line. For this purpose, I need to open Python prompt command and then type Python and path to Python code. Once I run execution, Python code will establish connection with Pipesim model and also open Excel file if it wasn't opened before. And then Python code will read information from the Excel file. We can see here this is new information received from Excel file, update Pipesim model, run simulation, and publish results. At the same time, in this example, Python code publishes the data in this console. I don't want to wait the end of the execution, so I will just close this line, this command prompt, and you can see that the new data were added in the second table. So you can investigate later this example, but as I already told, in this case, Excel was used just as a data storage. So let's move on to the next example where Excel is used as a user interface. So there are several examples. We can check, for instance, this build model, network model. Here we have two files. We have Excel file and the Python logic. In Excel file, if we open it, we can see multiple pages. In all examples, you will have introduction page, model page, and some additional pages. In the introduction page, there is a description, how to work with this example and why it was needed and everything else. On the model page, you will always see control elements. And the same control elements are used in other examples. So I'm not going to continue with this example, so I will close it. I'm going to move on to Excel template. Now, this template can be used to develop your own example. In this folder, you have three components. In addition to Excel file and Python logic, we have model. So this model will be used to show this workflow. So I will run this template file. And similar as in the previous example, we have the two pages, introduction and the model. In the introduction page, I'd like to pay attention to the bottom part. Here you can find port number, the value is 0, and on the right side you can see the tip about this value, and we can see the installed Python versions. So these versions are installed on my machine. All of them are mentioned here, and you can see that I've selected all of them, and this is installed Python named range, so it will be used later. I will show you. The same happens with port number. It's also named range. So these named range are needed to simplify navigation inside the Pipesim workbook. So if we go to the model page, we can see that this page contains two sections. In the left part, we have the directories, Python directory, model directory, and model name. And on the right part, we have the control elements. Python directory contains the path to my Python version. This is a drop-down menu, so I can select any version installed on my machine. For instance, in this video, I'm going to use 24.1. We also have model directory, and it's not supposed that it will be changed by user. And we have the model name. I will leave it as is. And we have the control elements. We need at least two control elements. First is to establish connection with Python script. It means that server will be launched in the background. And the second button is needed to exchange the data with the server. So let me run Python script. Once I clicked on this button, the new window appeared, and inside the window we can see that the logic.py file was used to run the server. And now server is listening at port and ready to receive the command. So I will adjust slightly this window, and I will click on another button, Get Information. So once I click on the Get Information, the new window appeared, but this window will be closed soon. This window was used just to send the command to the server. Now server received this command, processed it, and reported that information is received. I don't want to do anything else with this example, so I can close the server. And if you want to repeat it again, you need to start the server again. So the server should be started in all examples. So once the server received my command, it processed the command and reported some results. In this example, I can click on the cell C7. It's called model info. And in this model info named range, Python code published a response from the Pipesim model. So we see information about web API version, Python toolkit version, model, and some unit system information. So this is a general idea how to work Pipesim Excel workflow. So we have Excel file, we run the server, and then we just send the command to the server and see how the results are processed and published in Excel file. But let's go deeper. On the menu, we have the Developer tab, and at the Developer tab, I click on Design Mode. Now I can change these buttons. So let's start from the Connect with Python script. If I do the double click, VBA code will be opened. In this VBA code, we have two methods: Connect click and Get Information click. So Connect with Python script runs this Connect click, and inside the Connect click, we first of all run the server, execute server script, and the name of the script is specified here, and then Get Information button status is changed to true. You've seen that it was grayed out at the beginning, but once I clicked on the Connect on the first button, it became available. And once I click on the second button, Get Information, the command was executed. The message Get Info was sent to the server. We can click on this workbook and find that this workbook contains the method workbook open. Inside this method, and I want to remind you that this method is automatically executed once you open the Excel file. VBA code, read information about installed Python versions, populate this information on introduction page, and if there is nothing on the machine, then the message will be shown that there is no Python toolkit installed on machine, and then update the port number, set it to 0 by default, and then deactivate the second button. So if you want to add the new button, you need to remember to change the status of the button when the workbook is opened, and then maybe change the status when you run this workflow. So let me close this example, and we also would like to check how it works. So let's check what's the architecture of Pipesim Excel link. For this purpose, I'd like to go to Pipesim Python Toolkit documentation. This is documentation for version 24.1. I will scroll down and find the section related to Excel, working with Excel. In this section, you can find the useful information, how to work with Excel, establish connection, exchange data, but below we can find information about architecture. So this architecture includes the workbook, client, server, files, and also the logic file. So let's review it carefully, step by step. Imagine that we have Excel file. In this Excel file, Excel workbook, we have only two buttons, Connect with Python script and function 1. So I do the click on the Connect with Python script. Once I clicked, the VBA executed the following command, execute server script. And the name of this script is logicpy passed as argument. Inside this VBA command, VBA will call this logicpy file. And inside of this logicpy file, the server py also will be called. This server py code find available port, bind host address and port together, then listen port and accept new connections and process messages. So by default, the status, the server is listening to the port and waits for the command. Now I want to click on another button called function number 1. Once I clicked on this function, VBA processed another command, execute command, with argument function 1. This command runs client py And the task of client Pi is just to establish the connection with the server and send the command. So the command function 1 will be sent to the server. Once the command is received by the server, the client is closed, and the server processes the command and runs this command if command exists inside the logic Pi. So let's go back to Excel template. I will close this example, and I'd like to change it. So we'll go back to the Excel templates. I will copy files. In addition to all these files in Excel template, I need to copy these command scripts. I will copy it to ctemp PTK. And inside of these command scripts, you can see that there are 4 files. Client Pi, server Pi, so all these files are needed to run the server and to run the client and exchange the data between the server and client. But you don't need to change anything. Of course, you can open and investigate these files, but right now I don't need to change anything. I just want to open the Excel template, open this template Excel file, and I need to enable connect to macros because I'm going to change something in this file. And here I want to add one more example. So let me just add one more button. Here I want to add one more button. For this purpose, I will select developer, click on design mode, then copy this get information button and paste another one button here. If I open the properties of this window, I can see that there is a name of this and there is a caption. In the caption, I will write get list of junctions. For instance, I want to get the list of all junctions inside my model. And I need to run the name. The name will be get junctions. That's all what I need. Now I can close it and do the double click. And the new function appeared here and I need to process. What I'm going to do, I'm going to send the command to the server. In my case, I will use the name get junctions and it will be the command for the server. And I already told you that I need to control this button, so I'm going to add it in the list of great button when we open the project. So I'll go to the workbook, copy this, and to be honest, I can use the sheet 2 object, then get junctions. This is my object name, and then status enabled, and then say false. So this button will be disabled by default when I open the model. And once I click on the connection, I'd like to enable it. So I will copy it here and change the status to true. That's all what I need to do in my Excel VBA code to process the new button. And now we need to work with Excel with Python code. So remember, these get junctions should be processed properly inside the code. So I will copy it. I can save the model. And now I need to open, not this one, this folder, logic Pi, and I want to open this logic Pi in the Python code. So let me move it here, and this is my example of the logic Pi. So let's review what we have inside this logic Pi. By default, first of all, we just load the path to the common scripts folder. And that's why the common scripts is needed, because it contains the necessary files to run the server and client. And then if these files are not available, we will report information that they are missed. Then we load information from this server, and we load some useful functions from utilities. For instance, this get model session is used to open Pipesim model, or if the model is already opened, we just establish the connection again to the model. And this get refers to range is used to simplify navigation in Excel file. So we will use it to get the data from named range or to update the data. Then below you can find some predefined name of the named range, Python folder, model file, or model info, for instance. And then we have several functions. I will skip them right now. I will go to the last part of this file. Here the key element of this file, so the main method. Once we run this file, the server will be started. And for the server, we will send two functions, handle port and handle message. In the handle port, this is the function. This function will be used by server to update information about the port. So once the server is started, the new port is found, and this information should be report it in Excel file, because later client will use this port to establish connection with the server. This is one thing. And another thing is the handle messages. This is the function which is used to process properly command from the Excel file. So if server receives the messages getInfo, then function getInfo will be executed. If server receives the messages getTests, then getTests will be executed. So if you remember, I used another one function I called getJunctions. So I'm going to process getJunctions and call method getJunctions, and call junctions are reported properly. And now I need to add getJunctions method because it's not available here. So I will find it was the getTest first, and I will change it to the getJunctions. So what's happened? Once you click get information, for example, there's getInfo, we run the connect model, or in my case for getJunctions we will do the same. Inside the connect model, you can see here that we read information from Excel file about the folder, file name, and everything, and we try to establish the connection with the file. If the session is already open, we just reactivate this session and work with this file. And then once the session is available, we have access to our model through the variable model, we can extract some data. In my case, when we run the getInfo, we receive information model about and publish it to the model info range. So let's do the same for list of junctions. So first of all, I want to get the junctions list. For this purpose, I need to use model find, and I will type all and then model components junction. And you can see that this model component is not recognized, so we can check what library we loaded, and we can see that we need to load from 6GIL definitions. We need to import all constants, and now the model components is loaded, so we can retype it junction. This model find will return the list of the junctions, and I want to update something in my model, so I want to publish this information. So edit here, and we will update. So what cell we would like to update? I don't want to update A1. So let's go to the Excel file. In the Excel file, I will type model junctions here, and I will update this cell. But for this cell, let me just type junctions. This will be the name of my range, and I will use this name to change Excel file. So I will type it here. And I expect that once I send command getJunctions to the server will call method getJunctions, then connect to the model, find list of all junctions inside the model, and publish it to the named range junctions. So let me save this logic file, and then I will establish the connection one more time. I need to revert back the design mode, so I will be able to run it. Connect with model. So the model is connected. There is no error message. It means that syntax is correct. And now I can immediately get list of junctions. So we can see the report from the server. So the model is opening, and there is a response. Junctions are reported properly, and we can see that this value contains manifold. It means that the model itself contains only one junction. That's all what I wanted to show you in this video.